help you?
Looks like we just need to use the trigonometric identities to solve it.
Okay, to first solve the problem, you have to factor out. And once you factor out, the cosecant x's cancel. And it leaves you with secant squared x minus 1. And then that's one of our identities, which makes the change into cotangent squared x. Boots, do you know what we do from there?
Sure. First, we can use the quotient property to get cosine squared x over sine squared x. Now we'll need to use the reciprocal property to get 1 over secant squared x over 1 over cosecant squared x. Then we can multiply by the reciprocal, and once the ones cancel out, we get cosine squared x over secant squared x, which is our answer. We got it, guys!
Looks like we're having to solve those problems to cross the bridge.
To get across the first step, we'll use the subtractive identity to find the sine of pi over 12, which we've simplified to pi over 3 minus pi over 4. Now we'll just use the formula for subtraction identities of sine. Now we'll plug in the values so that x is pi over 3 and y is pi over 4. Using the information from the unit circle, we know that sine of pi over 3 is square root of 3 over 2, and cosine of pi over 4 is square root of 2 over 2, and cosine of pi over 3 is 1 over 2. Once we multiply those out, we get our answer of square root of 6 over 4 minus square root of 2 over 4, which then simplifies to square root of 6 minus square root of 2 over 4. Now we can move on to the next problem to get to the next step.
Okay, to first solve the problem, you have to find two fractions that either add or subtract to equal pi over 12. And then you plug it into the additive cosine identity, and then you look at your pie chart and you fill in the fractions for it. And then you multiply out the fractions and you add them, and then you get the answer. Okay, for this problem, you use the tan additive identity, and you fill it in with pi over 3 and pi over 4, and then you solve for tan pi over 3, tan pi over 4, and then you simplify the fraction.
Hey, we did it! Look, cars, we can use that to get to math class.
Okay.
Ooh,
Looks like we could use some identities to solve these.
First, to get the car to go, we have to find cosine of pi over 8 using the half angle identity, which is why we did pi over 4 times 1 over 2. We then plug that into the equation, and then we can simplify cosine pi over 4 to square root of 2 over 2. Then we get everything to be like terms, multiply everything out. You get square root of 2 plus square root of 2 over 4. Since 4 is a perfect square, you can get that as 2, which will give us our answer. Square root of 2 plus square root of 2 plus square root of 2 over 2.
Okay, for this problem, you have to use the half angle identity for sine, and then you find out what cosine of 3 pi over 2 is, and then you have to get common denominators for the numerator, and then you divide by 2, and then you simplify.
So now we're going to use the double angle identities, but we only have one angle. We know that it's in the first quadrant, so we'll draw a triangle and find all the sides and use it to find the other angles to do the problem. Now that we have all our values, we can find sine of 2x, and all we have to do is plug in our numbers into the equation and we've got an answer. Now to find cosine 2x, we take our values needed for this problem, plug them into the equation, and then you'll get an answer that way. Last but not least, we have tangent. Okay, tangent is a bit tedious, but once again, it's just plugging all your numbers, necessary numbers, in this case it's just tangent that you need, into the equation, doing your simple math you've been doing since like forever, and then you get your answer. We did it!